Welcome to Demystifying Math. In this lesson we're going to be discussing polar coordinates. Specifically we're going to plot polar coordinates, and we're also going to be converting between polar coordinates and rectangular coordinates. Alright, so the first thing that we need to do is familiarize ourselves with the polar grid. The polar grid has a pole where you're normally used to seeing the origin. It also has an x-axis, which we're going to call the polar axis. And the vertical axis is going to be called the line theta equal pi over 2. Now I've broken up the grid into units of pi over 12. And I have 6 concentric circles drawn. Each one of those circles has a radius length of 1 unit longer than the previous one. So for our first circle here, this is a length of 1 for our radius. For the second one, our radius length is 2. And then we have a radius length of 3 for the third circle. And then we go all the way out to 6. Now normally a polar grid would continue on forever and ever, just like an x and y axis continue on forever. Okay, so what we want to do is be able to plot some ordered pairs. When we plot ordered pairs on a polar grid, we're plotting in terms of radius length and angle measure. I'm going to be plotting in terms of radians, but you could also do this in degrees. Okay, so what we're going to do is plot some points. Our first point that we're going to plot is the ordered pair 1, pi over 4. When you go to plot these points on a polar grid, you're first going to find your angle measure. So we're going to go to pi over 4. And then we want to be 1 unit away from the pole. So we're going to plot that point and we end up right here. Let's try another one. Suppose that we wanted to be at 2 pi over 3 for our angle measure, and our radius length is 3. So we're going over to 2 pi over 3, and we want to be 3 units or 3 circles away from the pole, or 3 radius lengths. Alright, our radius length is 3 here. Alright, let's try another one. Suppose that we wanted to be at 7 pi over 6 and 4. So we have 4 for our radius length, 7 pi over 6 for our radian measure. So we're going around to 7 pi over 6 first, and then we're counting 4 radius units away from the center. Now let's try another one. Suppose that we wanted to be at 4 pi over 3 and 5. So our radius length is 4 pi over 3. Our distance away from the pole is 5. So we're going to be here. Now we could also say that's the point, pi over 3, and a negative radius length. What I want you to kind of think about is each one of these lines that we have drawn here as an axis. So when you have an x-axis or a y-axis, you actually have both a side that's positive and a side that's negative. So if we're looking at pi over 3 and we're saying negative 5, that means we want to go to the negative side of the pole. So we would be in this exact position that we were before. Now if I had said to you negative 5 and 4 pi over 3, that means we're going to go to 4 pi over 3 and go to the negative side of the pole, which is going to put us on the pi over 3 line this time. So what you can think about is each and every one of these points, you can have lots and lots of different ways of measuring them. So if we're using a negative radius length, we're going to go on the other side of the pole. If we're using a negative angle, we're just going to go in the clockwise direction to find it. So for instance, if we went to negative 2 pi over 3, let's put a 4 for our radius length so we can see where it's going to land. So we had positive 4 and negative 2 pi over 3. Well, 2 pi over 3 is here, but we want to go 2 pi over 3 units in the negative direction. That's going to land us on this line. And then we wanted to be, again, 4 units away from the pole. Now we could have also done negative 4 and negative 2 pi over 3, both being negative numbers, and that's going to land us on the pi over 3 line. So we're going negative 2 pi over 3, but we want to be 3 units on the negative side of the 4 pi over 3 line. So that landed us here. Now you also have points that land on the axes. So remember, your horizontal axis is called the polar axis. At the polar axis, your angle is either going to be 0 or 2 pi in terms of radians. So let's say that we wanted to be at 3 with a radian measure of 0. So this angle measure here is 0 and my radius length is 3. Now if I wanted to be on this side, I could either use a negative radius length and still keep my angle as 0, or I could use a positive radius length and an angle of pi. So we have that one there. Now anything with an angle of pi over 2 is going to land us on the vertical axis. So let's say that we wanted to be at 4 and pi over 2. We're going to land here. Of course, so if we wanted to be on the 3 pi over 2 line, we could just say 4 and 3 pi over 2, and we would land there. Or we might say negative 2 and pi over 2, and that's going to bring us to the opposite side of the pi over 2 line. Now, if you want to land at the pole, that's pretty easy to do because it doesn't matter what your angle measure is. If your radius length is 0, it's going to put you at the pole. So you get right to that point there because you're not moving away from the pole at all. Okay, so that's pretty good as far as coordinates go. So let's go back to our slides. Okay, so what we saw was there's several ways to write any of the ordered pairs on a polar grid. Usually with an XY plane, you can only do it in terms of X and Y, and each and every point is distinct, and with only one ordered pair that represents them. But on the polar grid, you can have an infinite number of points that represent ordered pairs that represent a point, because you have lots and lots of coterminal angles that you can use. But when we're looking on the polar grid, and we saw that we could use negative radius lengths to get to the same point, the angles have a relationship between them. For instance, with 4 and pi over 3, you can also express it as negative 4 and 4 pi over 3. Now, the relationship between pi over 3 and 4 pi over 3 is that you're adding pi to it, or you're rotating 180 degrees, whatever you want to think about it, but you're moving it pi units around the circle. So that's going to be adding pi to your angle measure and taking the opposite of your radius length. So you can get another way of writing it just by doing that. You could also rewrite it as 4 and negative 5 pi over 3. Now the relationship between pi over 3 and negative 5 pi over 3 is that they're coterminal angles. All I did was subtract 2 pi from pi over 3 to get to the negative 5 pi over 3. Of course, I could add 2 pi to my angle and get all kinds of coterminal angles as well. Okay, so let's look at this coordinate. We have 1 and 17 pi over 12. So my radius length is 1, my angle measure is 17 pi over 12. So I could take the opposite of the radius length, make it negative, and then add pi or subtract pi even from my angle measure, and I can get another way of expressing the point. Now in this case I subtracted pi because I started off with a large angle. So 17 pi over 12 minus pi is the same as subtracting 12 12ths pi, so I got 5 12ths pi. And then I could also find coterminal angles, and in this case I subtracted 2 pi to get a coterminal angle and I got negative 7 12ths pi. So there's at least 2 different ways for you to rewrite the coordinates. Okay, the other thing that we want to be able to do is take coordinates that are given in rectangular form and rewrite them in polar form. Now keep in mind that when you are expressing these coordinates, they're going to be plotted in exactly the same position on both grids. It's just that with the polar grid, we're expressing the ordered pair as a radius length and an angle measure rather than an x and y ordered pair. Okay, so we want to convert back and forth. So let's look at this. If we have 3, 6, we need to know what the radius length is coming off the pole or the origin, and we also need to know what the angle measure is. And that's pretty easy to do. With the radius length, we can do that using a Pythagorean theorem. Now normally it's a squared plus b squared equals c squared, but our leg lengths are determined by x and y, and our radius length is the hypotenuse. So we're going to do x squared plus y squared equals r squared. So plugging in for x, we have 3 squared, and y is 6, so we have 6 squared. And then simplifying, we get 9 plus 36, which is going to give us 45. So we have the square root of 45, which is 3 square roots of 5. For our radius length. Now what we're going to do is go and find our angle measure, and I estimated it there. So remember that the tan is going to be opposite over adjacent, so that's always going to be y over x. Then we're going to take the inverse tan of the y, which is 6, over the x, which is 3, so the inverse tan of 2. And you can put that in degrees or radians. I'm trying to stick to radians here, but you can do everything in degrees. So we got the ordered pair about 6.7 and 1.1 for our polar form. So think about a circle going around there. Okay. All right, so what we want to do next is convert another ordered pair. So we have this rectangular ordered pair, which should be kind of familiar to you, of negative square root of 3 over 2 and negative 1/2. And what we want to do is convert it to polar form. So we need an angle measure and a radius length. So looking for our radius length, we're going to plug in our x and our y and square them. And then adding together, we get 4/4, which is 1. So our radius length is 1, which we should expect because you should recognize this as an ordered pair on the unit circle, which is really just the polar grid. Okay, and then we want the tangent of the angle. I call this angle alpha. All right, so it's opposite over adjacent, so it's going to be negative 1/2 over negative square root of 3 over 2. Then multiplied by the reciprocal, and I rationalized it. So that's square root of 3 over 3. So your angle measure is going to be, in this case, pi over 6. But remember that your coordinates are in quadrant 3 because both x and y are negative. So you need to make an adjustment when you use the arctan to get your angle measure in the right quadrant. So that would be pi more units. So it would be 7 pi over 6. And a radius length is 1. Of course, I could have used a negative radius length and pi over 6 if I needed to. Just make sure that when you give your coordinates in polar form that they land in the correct quadrant. Okay, now we want to work in the other direction, and we want to convert from polar to rectangular. So I have this polar point given to me of 3 and 7 pi over 4. And I know there's a relationship between x and y and our radius length and our angles. So x is r cosine theta and y is r sine theta. So plugging into the r cosine theta, I get 3 cosine of 7 pi over 4. And the cosine of 7 pi over 4 is square root of 2 over 2. So I simplified to 3 square roots of 2 over 2. And the sine of 7 pi over 4 is negative square root of 2 over 2. So you have negative 3 square roots of 2 over 2. So that's going to put us in quadrant 4. And we have our coordinate pair. Okay, so let's look at one more. We have 4 and negative pi over 3. And we're going to plug into r cosine theta for the x coordinate. And the cosine of negative pi over 3 is 1/2. And for sine of negative pi over 3 is going to give us negative square root of 3 over 2 times 4, or simplified to negative 2 square roots of 3. So we have another coordinate in quadrant 4. So we have 2 and negative 2 square roots of 3. Okay, thank you for tuning in to Demystifying Math.